Good afternoon, everyone. I am Sahiti Priya from EEE department. Today's seminar is about using hydrogen as an alternative fuel for a sustainable future. So these are the topics which we cover in today's presentation. Let's get into introduction. So next slides. Let's get into the introduction. As we strive for sustainable future, hydrogen has emerged as a promising clean energy carrier with its zero emission properties. So let's learn about the hydrogen and discover its potential to shape a cleaner and green future. Next slide. This is the overview about hydrogen. Hydrogen is the simplest and abundant element. It consists of only one proton and one electron. By using hydrogen, we can generate electricity and heat. So, when hydrogen reacts with oxygen in a fuel cell, it produces only water vapor and heat. Thus, we can say it is a clean energy source. But why only hydrogen? Because it is a clean fuel with zero emission and it is a renewable. And it has a potential to store excess energy. That is, it acts as an energy carrier. Next slide. Role of hydrogen in global energy transition. It helps in decarbonizing the sectors in which that are challenging to electrify, such as heavy duty transportation, etc. It supports for renewable energy integration. So next. So these are the forms of hydrogen. There are few types of hydrogen which are produced with different methods. Few types are green hydrogen, blue hydrogen, gray hydrogen, pink hydrogen, and brown hydrogen. These are produced using different methods. We will know more about them in future slides. The most commonly used form of the hydrogen is green hydrogen because of zero emission. So next. Now we will see the key differences. So now we will see the key differences between traditional fuel versus hydrogen fuel. Hydrogen energy will produce zero emissions as compared to traditional one. Also, it is renewable while traditional fuels are not renewable. Hydrogen energy has high efficiency, but traditional one has low efficiency. Next, hydrogen can be used as energy carrier while traditional energy has limited storage. And lastly, we can see a common applications in both of them, like electricity generation, transportation, etc. So next. Hydrogen production methods. Here we can see various methods which are produced for production of hydrogen. Firstly, electrolysis. In this method, by using electricity, we split water into hydrogen and oxygen, and it is more preferable for renewable sources. And next is steam methane reforming method, which is most commonly used for producing hydrogen from natural gas. So mandatorily, we should use carbon capture and storage technology because in this method, it produces carbon emissions. And next is gasification of biomass. It involves of converting organic materials into hydrogen. And next one is thermochemical water splitting method. It is a high temperature method in which water is split into hydrogen and oxygen. And some other methods are also used like photocatalysis and biological process. So in this slide, we are going to learn more about most commonly used hydrogen production method, that is steam methane reforming. In this process, it involves the reaction of methane, which is primary component of natural gas, along with H2O, the presence of and catalyst. It involves 4 steps, that is pre-reforming, reforming reaction, water gas shift reaction, hydrogen purification. So next. In first step, natural gas, that is nothing but methane, will go through a pre-reforming stage where it is partially converted into carbon monoxide and hydrogen to prepare it for reforming reaction. And the second step is reforming reaction. Here, the pre-reformed methane is exposed to steam at high temperature and high pressure in a reforming reactor. So, here we can see the reactions that occur. Methane reacts with steam to produce hydrogen and carbon monoxide. And so next. In third step, we can see water gas shift reaction. Here the carbon monoxide which is produced in second step is further reacted with steam in a shift reactor to produce more hydrogen and carbon dioxide. We can see the reaction involved in it. In this step, it increases the hydrogen yield. And the last step is hydrogen purification. Here, the resulting gas mixture is called synthesis gas or syngas. It contains hydrogen, carbon monoxide, and carbon dioxide. From this step to obtain pure hydrogen, purification methods like pressure swing, adsorption, or membrane separation are used to remove impurities and separate hydrogen from the remaining gases. Here we can see we can see the overall reaction which is produced in this method. To reduce the CO2 in this reaction, we use carbon capture and storage technique. So next we will see the applications of hydrogen energy, like hydrogen cells are used in transportation for clean electricity production, and it is used in many industries. Also, it is used for energy storage, and it is a clean alternative for residential and industrial heating. Next, we will see the advantages of hydrogen energy. It is a zero emission technique and it also acts as energy carrier. It has a potential of decarbonization and it can be produced in various techniques like we have seen in last slides, and it reduces the dependency on fossil fuels. So next, let's see the challenges involved in it. Green hydrogen is expensive to produce and also it is economically high for storage and transportation. Also, it has less efficiency compared to batteries and it produces carbon dioxide in production method. Hydrogen is also a highly flammable gas, and also technical and market adoption are still developing. The last, next. Now, lastly, the conclusion. We have came to know about the hydrogen's vast potential as a clean, sustainable alternative fuel. In future, the hydrogen will play a crucial role in our transition to a low carbon economy. Thank you.